So, hello everyone. Hello everyone. Hello everyone. Yeah, so everyone is awake. Good. So, welcome to the second day of XMLPrague. So we are always happy to have you there every year. And I see new faces, which is always very good. And that's fine. So today we are going to do two things, mostly. Sitting and eating. Drinking is optional, okay? You can do it if you want, but it's not mandatory. And so for the sitting, it will be all the day in this room, no problem. And for eating, if you were there yesterday, that's the same place, okay? And the coffee breaks, it's over the two rooms over there, just for a very simple organizational blah, 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 blah stuff. Second thing, you need to keep your coffee, every glasses or everything outside of this room. That's the rule. We try to not break it too much every year. And that's basically it. You have Wi-Fi access written on your badge if you're new to this conference. So you can access to the Wi-Fi. It's supposed to work for all the people in this room. Maybe more, but for the moment. It works so far. So if you have any issue, that's great. Remember, you're filmed, every one of you. So you're on the web, okay? So me too, okay? So we can see your face and people can vote if they want to keep you for the next day. Remember that when you're doing stuff, especially when you're asleep, okay? So that's the beginning of the conference. And as usual, I want to thank all the people that makes it possible, and especially we want to give some special thanks to the sponsors, because they are the people who made it possible every year, because bringing a lot of people over there and organizing stuff is always a lot of fun, but we need to make it technically possible, and they made it possible. So I want to thank, and in order I want to ask 3 of our 6 sponsors. We have 6 sponsors this year, 7 even. One is a pseudo-anonymous sponsor, but is not anymore anonymous. I see you there. So to thank our sponsors, so I will give them a few minutes to explain them why. Nobody understands every year why they want to sponsor XMLPrague. Nobody knows. It's a mystery, and they maybe try to explain it for us. So I would start by Antenna House and Mike, if you want to say a few words.
Again, I'd like to start this year by thanking all of you for coming to XMLPrague. We certainly appreciate the opportunity to help sponsor the event. Antenna House sponsors and participates in numerous events each year, but we always consider XMLPrague to be at the top of that list. The quality of the presentations and the people who attend make this very worthwhile for us, and we thank for all the people who are here. So again, thank you. And I'd also like to thank you all for coming out on my birthday today.
Oh, hey.
And
Lucky
invite
teenager.
you to my birthday dinner at the monastery.
Yeah. You can invite a lot of people.
Yeah. Thank you.
Thank you. One other sponsor is Vaclav, which know this conference maybe more than me, because he himself since
Unfortunately, I am not sponsored, the company is sponsoring. Yeah. I wanted just to say 2 sentences. First, X definitions are, after, I think, more than 10 years, released to public usage. So I wanted to remark that you have the possibility to see the poster upstairs, and you can download it from the website xdev.cz. So that's all what I wanted to say.
Perfect.
Tomorrow maybe the company, Cynthia, will present itself. So
Thank you. Thank you, Vatta. And the third for tomorrow is for today. I'm already asleep. Okay. For today is Gerrit. Gerrit is taking more and more space in this conference. If you don't see that, okay. He's organizing a lot of stuff. He's bringing students. He's bringing half of this town to this conference.
And pastry.
And pastry, even. So please, Gerrit.
Yeah, thanks for having us again, and thanks Jirka that we this year also have our logo and on display. It was
Eventually.
missing. Yeah, it was missing last year. And those of you who've been here last year remember that we were promoted to being the second largest sponsor right after Oxygen. And the reason was for this that there was no demo jam 2 years ago. So we said, okay, if we increase our sponsorship, maybe we can have a demo jam again. And we had a demo jam last year. And therefore, I was really shocked. I didn't just made it up. I was really shocked when Jirka told me there would be no demo jam today. Because
Nobody's interested about demo jam.
Because I think demo jam is a human right. So, so maybe my first reaction was, Jirka, nice sponsorship that you're having here. Would be too bad if something happened to it. But on second thought, maybe let's have an applausometer style voting whether we should have a demo jam next year or not. Or maybe even this year. So who's in favor of well, having more time to chat after dinner? Or who's in favor of having a proper demo jam? So option 1 is a bit more time to chat. Applause. Okay, Hans-Jürgen. and who's for a demo jam? I think the case is settled.
Okay, thank you, Gerrit. I knew you want to hijack this conference, and you did. Congratulations. So maybe we'll reconsider this demo ham something things to do. So today we will start by Bert. I think it's his computer here. Is it? And he wants to makes us jump to the new funky, interesting keywords of the moment, which is AI. Okay, so AI, so artificial intelligence and software that does everything itself and so on and so forth.
Test, test. Can you all hear me? All right. Yeah, okay. So, welcome. My name is Bert Willems. I'm the product architect at FontoXML. And today I'll be talking to you about assisted structured authoring using conditional random fields. I will start by explaining what the actual situation is, explain why structured authoring is not, well, it sometimes is hard for people to do. So there's a problem with adoption rate, for example. And I will explain how machine learning or artificial intelligence, or in this specific case, conditional random fields, will be able to help with that. So if you want to tweet about something, my Twitter handle is dev@work, so feel free to do so. So structured authoring examples. So in the first example, I just pulled some information about Wolfgang Mozart from Wikipedia, and I basically highlighted in the green, I highlighted the words that are very interesting. I mean, if we think about it in terms of the information that's embedded in this piece of text, it's very valuable. For example, if I have the name Mozart, I can infer that he is a composer in the classical area, so I already know quite a lot about this particular person. I have the date of birth and also the day that he passed away. The second example is from a pharmaceutical product. In this case, it's aspirin. It tells me in what size the aspirin actually comes. In this case, the 300 milligram of tablets. And the dose form is 1. Again, there's plenty of information in that particular fragment of text. So why is that important? So nowadays, people have less and less time to actually read anything. So they want to basically type in a search query, if you want, in an online interface, maybe in an app on the phone. And they immediately want to find the right information. So when we take the information that is implicitly embedded in this text, we can actually construct a knowledge graph from this, saying that, for example, that the aspirin, you can take that every 4 to 6 hours, right? So using that information, using that knowledge graph, I'll be able to set up like a question answering system, which allows me to say, I'm using, I don't know, maybe 300 milligrams of aspirin. How much tablets can I take every single day? That's a question that I'll be able to answer using the data that is embedded inside this fragment of text. So what is the issue with just having information in text? Well, the problem is that human language, almost by definition, is ambiguous. And that's also a thing of beauty. But if you want to process information automatically, that's usually a big problem because you cannot be 100% sure whether the one thing is actually intended or the other thing. So can we use XML or markup in general to alleviate this issue? And absolutely. I mean, I think most of you will be able to write a schema for this. Maybe it's a data specialization, maybe a custom schema, DTD, what have you. You would just introduce a few tags. Well, maybe a tag that says, well, this is product name, this is dosage form, this is a time range or a date range, if you will, all of that stuff. So we're good to go, right? Well, in some cases, that's actually good, but someone needs to put that markup inside the document, annotate the text, if you will. And based on some user experience testing that we've did at Fonto over the last year, we learned a lot that subject matter experts, so the people who are supposed to write this text, actually see applying the markup as an additional burden to their work. Because in most cases, they come from a situation where they are used to Microsoft Word. They just write the text, ship it off, and probably the best thing that ever happened to that particular text is that it ended up as a PDF or a printed document somewhere. But of course, if you want to do stuff like the question answering systems that I just explained, it's quite hard to do that from just a text only. You need the disambiguation in there. But SMEs, they're actually not happy to do that additional work because in Word they didn't need to do that, but in the XML world they often are asked to do so. So one solution, of course, would be to get someone else to do the job. I mean, that's particularly easy. However, that might not be the most cost-effective way of doing so. So the idea that we set out is basically, can we automate this? I mean, if we can automate this, computer power nowadays is fairly cheap with the prices at AWS or Azure or something like that, incredibly cheap nowadays. So we have a lot of processing power at hand, but still human capacity is still expensive in most cases. So what we envisioned is basically, well, what do people already know? So I'm talking about the non-XML experts here, the subject matter experts. They are probably very familiar with Microsoft Word. I think most of us here are. And of course, there's a very helpful feature, which is the spell check capability. The spell check actually helps you write a well-written document. If there's a misspelling, of course, it will detect so, and it will provide you with suggestions. So it's actually a helpful tool, but it's not really intrusive. It doesn't block you from continuing your work. If you want to keep the spelling error in your text because you're still rewriting everything, that's fine. So you're not forced to fix everything at one go. So what we want to achieve is basically the same user experience. That means that instead of checking the text, whether it's spelled correctly, we want to check whether the markup or the XML annotations are applied correctly. So we want to be helpful and suggest markup, but we don't want to be intrusive. We don't want to force people to apply the text at the time. We want to be able to allow them to choose that moment when they're ready to do so. Yeah, one more thing is that we will try to do that with machine learning, which is of course a big topic nowadays. There's a lot of buzz going around that. I think literally every day about 50 or 60 research papers in this area come out, so there's a huge investment. And machine learning, or even a higher level concept like AI, is a very broad field of study. So what does machine learning actually mean? So machine learning is really a way to get the computer to be able to teach the computer and to allow it to self-learn without the need of explicitly writing a program against it. I mean, if we need to write a program, there needs to be a human involved, which of course takes time, and time is money, as we all know. So in this specific case, I'll be talking about a subfield of machine learning, which is called natural language processing, although it's technically not a subfield. It's like there's a big overlap there. And natural language processing is a way of dealing with text based on machine learning. And in this talk, I will be focusing mostly on what we call text classification. And text classification really is recognizing certain patterns in text. So bear with me. We'll do a bit of deep dive into give you an insight in how such an algorithm is constructed, and then I will explain what we'll actually do to get that classification once we have that, and get that back into the XML, and see how we can actually use such a mechanism to help users achieve their task more quickly. So really the anatomy of any machine learning system is basically 4 components. So we have our input, and the input can really be anything. So it can be an image, can be a video stream, but in our case it's either text or an XML DOM if you want. But it's just the input on which we want to basically do a classification on. Then we have the model and the weight. The model is really a mathematical function that is able, based on the input, produce the expected output. So how do we get such a system to learn? is that basically we need two more components. So one is the loss function, and the loss function is really a way, again, in mathematical terms, to determine how wrong our current model is. So given the input and an expected output, how far off are we, right? So that's loss. And what we will try to do is using a thing called training. And training is really give it an example input and the expected outcome, so we'll be able to determine how accurate the system is at that point in time. So once we put in some training data, so like maybe 100 examples, both of the input as well as the expected output, we will be able to determine how to update the model and the weights, which is basically numbers, how to update them in order to get the system to understand what we're trying to teach it. So in other words, we're trying to minimize the loss. So we try to minimize the wrongness of the model. And that entire process is called backpropagation. Basically it's a whole bunch of math that happens under the hood here. I'm not going to explain all the equations. They're based on each model. There are different equations. There's a lot of study going on, and I'm not really the person to explain all of that to you, granted that we have very little time to talk about this in 20 minutes. So during my research that I did for the paper I wrote for XMLPrague, I used an algorithm, or a model, if you will, called conditional random fields. And conditional random fields is an algorithm that has been around since 2001. And a nice property of conditional random field is its ability to not only look at a certain word in a given text, but also look at the surrounding context words. So basically the two words that happened before the word that we try to classify, and the two words behind it, at least in my case. It's in machine learning, basically all these parameters, as we call them, hyperparameters, are subject to configure. So I could either say I have a context of 2 words on either side, but I can also say I have a context of 5 words on either side. And what the task is that I set out the machine to do is give the whole bunch of bibliographic citations and classify it. And what I mean by classify is basically, given a bibliographic citation, I want to know which part is the author, which part is the article title, which part is like the journal title or the conference name, which part is the publisher, the date of the publication, etc., etc. I think in my paper I used like, I don't know, maybe 17 different labels, all to basically label the parts of a citation. And once we have the labels, we can actually translate it almost as a one-to-one mapping, or in most cases even, a one-to-one mapping to the XML. So that means that, for example, if we have an author label, so a particular part of the citation is labeled as an author, you could easily envision, based on whatever schema you use. In my paper, I looked at mapping it to JOTS and to TEI, which could easily do this with Ditto as well, or custom, because the label translates basically in the element name. Whether the element name is author or what have you, that's up to the schema designer to decide. But the overall idea is just get all the labels and store that in the XML. So, there's one problem with that approach, because up until now, we could perfectly automate this, right? I mean, we could run the algorithm automatically and update the XML automatically as well. Maybe you could set up an XProg pipeline or something like that to do that. But yeah, really this statement, nobody is perfect. That also goes for machine learning algorithms. Even the state-of-the-art algorithms today are not able to disambiguate in 100% of the cases. So that means that, yeah, it will sometimes make a mistake. And assuming, at least in our scenarios that we work for, having those mistakes is actually very costly. Things go wrong in downstream processing. Maybe the question answering system I described earlier gives you the wrong answer, which is maybe not too bad if it's about Mozart, but if you take the wrong medicine in the wrong dosage form, you can easily imagine that it's a big problem. So in order to reduce that, we said, well, we have an author working in our user interface. So we have the subject matter expert who should be able to disambiguate, and of course that's a human as well. But what we do, instead of applying the markup automatically, we give a suggestion, really like spell check, to apply the markup and give an indication of where certain ambiguities exist, because the model is actually, in most cases, able to calculate where it's very certain that a certain label applies and where it's a bit doubtful whether it's the correct one or not. So to give you an impression of such a user interface, in this case, I set up a bibliographic citation, and most of the tags are already in place, so there's no ambiguity there. So, for example, Crystal Popple is the author of this particular part. We have Chemnitz probably as the publication place, so the machine is very certain that those labels or that markup is actually correct. So it doesn't ask the user, is this really correct? No, the machine is very confident, so we apply that. However, in the two cases, especially around the titles, it's very hard for the system to determine what type of title it is. So if we look at the Musikgeschichte in Mittel- und Osteuropa, that could either be the journal title or maybe the series title. In this case, I also added the certainty, so the machine thinks it's 95% certain that it's actually a journal title. But in some cases it might be wrong. It might have predicted the wrong label and it's actually a series title. And as an author, you'll be easily be able to correct that. And of course, once I click the apply markup button, the actual value, so the decision of the author, is stored in the XML. So it's actually disambiguated at that point in time. So where are we today? The conditional random field implementation is done. I wrote that in November or something like that when I did the actual paper. Took me a week to do so because I wanted to port the one existing algorithm to .NET Core. That's my preference runtime. And I did some experimentation on the accurateness of this conditional random field algorithm. And it turns out that for citation tagging, it's actually pretty accurate. I think it's around 99% accurate. So that means that only in 1% of the cases it mispredicts a label. So that's actually pretty good and pretty helpful as well. That means that hopefully only in 1% of the cases the author actually needs to make a change. So that should save a lot of time. The user experience around this, I put here meh, which actually means that I'm not too happy with it. I did the design myself, and I'm definitely not a user experience designer. So there's plenty of room for improvements, make the screen that I just showed you more intuitive to understand. Actual integration, so we have a mock-up of the UI. I have the actual algorithm in place. We have the infrastructure in place to get text and XML analyzed and send back the responses, but I just didn't have the time to integrate everything. And actually, the most important step that I'm still missing here is that we actually need to take this into production, which means that for us, we need to put it into the hands of the author and allow the person to actually work with the system on a daily basis, not just as an empirical study, but real, actual production usage. The final piece that's really a continuous area of research is using different algorithms. For example, the conditional random field algorithm can only look at 2 words in the, or 3 or 4 words in the context. So it means that it has a very narrow view of the text, or the DOM structure, if you will. Other algorithms like the recurrent neural network algorithms, it's a whole different category of algorithms, are actually much more powerful. They have things like memory built in, so the system actually has memory, so it can actually remember that it saw a piece of text maybe at the beginning of the sentence, so and at the end of the sentence it sees a different piece of text, and by knowing and remembering, actually remembering that first piece was there, it can actually reason much more powerful. So even though the conditional random field works pretty well for the bibliographic citations, I'm pretty sure that in other scenarios it will lag short due to its short attention span, actually. And recurrent neural networks, or LSTMs, are actually much more powerful, but also it takes more CPU time to process and really train the models. So hopefully, so our plan really is to put this into the actual user testing in the second quarter of this year. I'm fairly confident that next year I'll be able to provide you with the results and how much time we can actually save, and whether users will actually use this kind of systems, and hopefully go much more beyond the bibliographic citation implementation that I just did in my paper, but basically expand that to most, if not all, markup structures that you could envision in your XML documents. So I want to thank you for your attention, and I can imagine that there are a lot of questions. 20 minutes is really too short of a period to go deep dive into machine learning, but I will be here the next 2 days, and I would love to talk to you and explain more details, and maybe get some feedback from you guys, what you think, where you're currently working with. So really, thank you.
Nice, isn't it? It was Mozart. Sorry. So we have time for a question. Yeah.
Thanks for your presentation.
Can you present yourself? Just.
Hi, I'm Peter Lamers. I'm with John Benjamin's publishing company. Say that in your example you have 95% probability of a journal title, but in fact it's a book. And book was not one of the options, because journals have volumes and issues.
Yeah.
So this is clearly not a journal. It's not a series, it's a book.
Yes.
So how do you go about that as a user?
That's basically one of the areas where I did the design. I didn't come up with this particular use case, so probably, like you already suggested, we would find this in a usability study. And of course, instead of presenting a drop-down list here, we could have like a custom option in here as well. Another improvement that I would expect that we need to make in this particular user interface example is that you also need to be able to change maybe the author label or the publication place or something like that. So this is definitely not a final design or the only design that could actually work.
I'm a bit afraid that people will just take what the machine comes up with and say, okay, we will no longer work on the references, and end up with journal titles where they should be books.
Yeah, but the alternative scenario would be that they don't get any support, and probably they won't do any tagging at all if they don't feel like doing so. unless you force them to do so. And then we actually observed this, that a couple of customers, they actually had a huge impact on the adoption rate of structured content in general. Authors refused to do the work. So they said, well, here you have my, my old Word file, and then you don't make any improvements, or you need to hire someone else to do the tagging manually. So it's a balance between user experience, between what people want to do, how lazy people actually are. So that's a very interesting field of research of its own.
Thank you.
Thank you. Another question? Not much. Okay.
As for the user interface, if you want it to be non-invasive, I do like the way that schematron quick fixes work with Oxygen. So that's something that you might consider.
Yeah, absolutely.
My
So
users like it as well, which is more important than what I think.
yeah.
So you think we should standardize this?
Actually, the user experience pattern is like, it's spell check, right? So you have a red wavy underline, you'll be able to click on it, get some sort of user interface, whether it's a form like this or a schematron report message. It's from a conceptual user experience perspective, it's all the same pattern, but it's very powerful because people actually know it, and it's broadly applicable, like you just described it, to schematron, reports as well.
No other question? Oh.
I have not quite understood what is the initial input. Later, the subject matter expert decides. But I imagine that in the beginning, there's also subject matter expertise going into the initial setup to start the process.
Yeah, so so for citations, I assumed that the citations are actually keyed in manually. So it's just text input done by the subject matter expert. Citations, however, are usually, they come from a system like Zotero, where you can do research on Mendeley or something like that. So they sometimes are already a bit structured. But other things like the dosage form, in my other example, they are really keyed in manually by authors. I just came back from Basel, spoke to a huge pharmaceutical company, and they actually have hundreds and hundreds of users who currently type in all the data in Word and update those documents manually. And hopefully with a system like this, we will be able to support them, optimize that kind of work, that processes as well. But it's really the actual SME that types in the data to start with.
Okay. So thank you again.
Thank you.
So still in the editing topic, but this time is about distributing edition among multiple people. And our fellow from Oxygen is going to explain us how to do that.